Hi everybody. Today I'm going to show you, using consumer theory from microeconomics, how to solve a consumer optimization problem. In other words, you're going to have a budget, you're going to have prices, and you need to decide what combination of these two products are going to maximize your happiness or maximize your utility, as we say. So let's get started. Now we're a consumer, and let's say we've got two items. So we've got apples and we've got bananas. And these are two things that we like. We want to buy more of them because more makes us more happy. And let's say that we have a utility function that is given by utility, and it's a function of apples and bananas, right? So because both those things give us happiness, and let's just say that it's going to be equal to apples times bananas. Now, if you think about how this works, it gives us more utility if we have a combination of apples and bananas because we like variety. So if we were, for example, to have just like a lot of apples and very few bananas, we would have less happiness than if we had some combination, a more even combination of the two. And if we have 0 bananas, for example, and lots of apples, we would still have 0 utility. Now, in order to make this simple, let's just put in some simple prices. So we'll say that the price of apples is equal to 2, and we'll say that the price of bananas is equal to 1. Okay, so first off, what we might want to do is we could try and graph the situation. But hold on, we don't actually have a budget here. So let's create a budget line. And let's just say that for the sake of argument that we have 10 units of currency, so $10, say. So the way that we would write out this budget line very simply is 2 times apples plus 1 times bananas is equal to 10. And you can see that that's the budget line because, for example, if I were to spend, or if I were to buy 2 apples, that would be for, let's say, dollars in this case. And that would mean that I could then afford 6 bananas because, of course, the whole thing has to equal up to 10. Okay, so we've got pretty much everything that we need here to solve this because we've got our budget equation and we have our utility equation. Now what we want to do is we want to find the combination of apples and bananas, which maximize our happiness given this budget equation. So very simply, how we can do this is we can first figure out the graph. All right, I'm just doing this. You don't have to do this every time, but the reason I'm doing it is to illustrate this more clearly what's going on. So if we've got here, let's say apples on this part of on this y-axis and bananas on the x-axis, and I want to graph this, right? So if I were to use my $10 and I were to purchase 0 bananas, that means that I could then afford, let's say, 5 apples. And if I were to buy 0 apples, I could buy 10 bananas. So the graph is going to look like that. And you'll see that the slope is 1 over 2, right? Because the height is 5, the base is 10, so the slope is 1 over 2. And that is the slope of this budget line. In other words, minus 1/2 is the slope of the budget line. Another way that you could end up writing this is minus p x-axis over p of the y-axis. And if you see how that works, right, we've got the price of bananas is 1 and the price of apples is 2, so that's how we get this minus 1/2. Okay, so that's the slope there. Now, the slope of the indifference curves, well, if we take a look back here at the utility function, it's u equals a times b. And I'll just tell you that it's going to have an indifference curve. It's going to look something like that. It's going to have that nice concave shape. Now, if you remember from your basic microeconomics courses, the way that we maximize utility is we find the indifference curve that just is tangent to the budget line. So that's the highest amount of utility which is possible within our budget. Now, the slope of your indifference curve is the marginal utility of x over the marginal utility of y. I'm not going to go into why that is just here, but in a separate lesson you can learn that. And so in order to find out this optimal, let's say, point, all we have to really do is we can say, okay, at that point, the slope of the budget line is equal to the slope of the indifference curve. So remember, the slope of the budget line is here. The slope of the indifference curve is here. So we just set those two things equal to each other. Now, the slope of the budget line we have, it's minus 1/2. Okay, so I'll just write here 1/2. Okay, so that's 1/2. And the indifference curve, or the utility function you can see is a times b. So if I were to ask you what is the marginal utility with respect to b, then all you do is you say, well, it is, if we go back up to this utility function, we just take the partial derivative with respect to b. So the partial derivative is very simple because it's just, we treat a as a constant, and so the derivative of b is just 1. So the marginal utility of b of bananas is equal to a. It's going to be equal to a. And now what we're going to do is we'll take the marginal utility with respect to a. And that again, if we go back up here to the utility function, that's just the a becomes a 1, so the marginal utility with respect to a is just b. All right, so we solve this now and we get b equals to a. And to get a better understanding of what that means, that's the optimality condition. That means that the optimal kind of ratio of bananas and apples for you to buy is when you buy 1 apple, so when a equals 1, you will be buying 2 bananas. Right? So in other words, when a equals 1, b has to equal 2 in order for that equation to be satisfied. All right, so that's the first thing we need. Now, here's the thing. We have this equation, but remember, we also have our budget equation. And the budget equation was up here. All right, so I'll just rewrite it down here. So the budget equation was 2a plus b equals 10. Now, we have equation 1, equation 2. So 2 equations and 2 unknowns. So if we go ahead and solve those, we will get 2a plus 2a equals 10. So 4a equals 10. And we could rewrite that a little bit. So a equals 2.5. And so let's say that's a star. That's the optimal amount of bananas, or sorry, of apples for us to buy. And so if we plug that in to our, plug this a into here, so the a is 2.5, so 2 times 2.5 is 5. So that means that the optimal amount of bananas is 5. So if we buy these amounts, we will maximize our utility given our budget constraint. And that is it.